So there are different kinds of satellites. Communication satellite is there, navigation satellite, and there is another category of satellites we call as the Earth observation satellites, the satellites that we use for national resources. So in this case, I mostly deal with the Earth observation satellites that Indian Space Research Organization launches. So defining their configuration and using that data for different applications. So I specifically work in the water resources department. So now it was very challenging me to give this lecture, especially the audience belongs to the zoology background. So I did some work which had some linkage with the how this hydrology is linked with the aquatic life or river corridor management along the some of the case studies that we try to do. So I will try to give some of the how this satellite observation specifically can be utilized in the context of river corridor management, more specifically the habitat suitability along the floodplain area of the river. So this is the overall overview of river corridor management. And then, so before we directly move towards the application of satellite data, we'll try to understand what river corridor management is. So this is the slide where we'll try to understand how this engineering technology can be meet with the direct application in case of aquatic life. So when I say a river corridor or the channel is basically the narrow channel that allows the connection between two environments. Now, when I say river corridor, it is basically the area which covers your main river channel and the area on the left hand side and the right hand side of the river. So in India, if I specifically talk about, we have the Ganges River, Brahmaputra River, which have wide range of floodplain, which has the well-established aquatic ecosystem life. Like say for example in Ganga, you can see various aquatic life, like you have a dolphins, you have different kind of fishes, crocodiles. Now to sustain these kind of aquatic lives, there has to be certain amount of water should flow throughout the river, and how much should be the amount of water that should be allowed, and or which is the minimum requirement to sustain the ecological life. In that aspect, how the satellite data can be utilized, we'll try to understand through this particular lecture. Now, just going back to the history, as we belong to the Indus Valley civilization, throughout the world, we have the different kinds of civilizations. You have a Yellow River civilization, then you have this Egyptian civilization. Now, out of all these four civilization, if you see the one thing, the common is that all the habitat or the livelihood you will find along the river network or the floodplain area along the river. So, say more specifically, if I talk about the Ganga River, you will see that right from its upstream, where Ganga River originates in the Gangotri, Gomukh, to Til Farakka in the West Bengal. Uh, Hello, uh, am I audible, right? Hello, can anybody confirm? Am I audible?
Yes, sir, you are audible.
Okay, okay, thank you. So what I was saying, like in this valley civilization, say for example Ganga River, where it originates right from Gomukh, Gangotri Glacier towards it meets at the outlet point is the Farakka. So you'll see the various cities that being developed over a period of time. You have Kanpur, Prayagraj there. In the upper Ganga River, if you see, we have Haridwar, Rishikesh. So all these are well connected along the river. So that is why the maintaining the river front plays a vital role, not only for the aquatic lives but also the human requirements. Now, during this, if you talk about this river corridor management, you can categorize this the concept broadly into four subdivisions, maybe floodplain zonation, then water quality assessment, and the minimum flow requirement that should be there in the river to maintain the aquatic life, and the tourism and the recreation. So all the three categories, I will try to show that how satellite data can be utilized in all these four categories. This first one is the floodplain zonation. In layman terms, if you want to say, the floodplain zonation is basically the marking of the area which has the probability to get inundated during the monsoon season. So again, uh, especially in the monsoon season, we have the recurring heavy rainfall events that we face every year, because of which uh, along the Ganga river, Brahmaputra river, and some Himalayan rivers which experience the flash floods, uh, we we do know that in this particular area every year inundation occurs. But what is the exact extent of that area, that is what we should require for policy making purposes, and then different infrastructure developments in that area. So there are various methods that can be done. One of the method that you can use is the satellite observations as well. So again, why we need this floodplain zoning is basically, briefly if I talk, around 40 million hectares of the geographical area of India is prone to the floods, which is a high number when we talk about the around 3,290 lakh of hectare is the total area of our India. Now, out of this, this is one of the flood affected areas in India, that is being the area. This is the report made by the NRSC, National Remote Sensing Center, Hyderabad. Again, this is the one of the unit that comes under the Indian Space Research Organization. So this is one of the major application of satellite observations, how you can use for flood inundation mapping. So more specifically, if I talk, you can see that this is the one of the uh, data that is showing the rainfall along the different regions of the India, and this data is from the Global Precipitation Mission, and this is the monthly data for the August month of 2020. So here I could see that what is the rainfall at various states of India. Now, this is just one example. The idea is that as you can take as much as satellite images, if you process it, you can get a glimpse of a large area, and you can measure the rainfall, which is quite not possible when you install the instrument at a typical location and measure the rainfall. So more specifically, if we try to go into the Bihar region also, this is one of the data that we processed. This is the image of July 23, 2020, and this is again the rainfall product. So here you could see on the left hand side, this is the monthly rainfall for the July month of year 2020, and I could see how what is the variation of the rainfall over the complete India. So this is what the advantage of satellite observation. In one glance, you could see where there is a high rainfall and where there is a less rainfall. So now for this particular month, you can see in the Bihar state, there was Bihar and the Uttar Pradesh, there was the heavy spells of rainfall events, which again lead to the inundation in the downstream areas or along the river. So not only you can map where there is high rainfall, but also you can see that which area gets inundated. So this is on the right hand side. You can see the blue color is basically the flooded water that is there, which we try to map using the satellite observation. So we use Sentinel-1, which is again the name of satellite, to map this inundation area. Now this is throughout the Bihar, different districts of the Bihar state, where we try to analyze this October 2019 flood event. And if we look into the different color schemes, so this cyan color is basically the permanent water of the Ganga river, and the other colors, especially the red, the pink, and the green you are seeing is the flood water. The red color represents where water stayed there for three
Sir,
days Hello.
slide is not movable.
You are still in the first slide. Which slide you are seeing? Hello. I will just reshare the slide. Is it visible now?
Yes, sir, it is visible.
Okay. So what I was saying here is that this is the image where we try to map the inundation. Now this the red color is basically the representing the inundation which occurred. Water stayed there for 3 days. 8 represents where water stayed for 8 days, and green one more than that. So such kind of inundation we can map. By this kind of analysis we can know out of all the different states which district is more prone to the flood, within that district which blocks are more prone, and where more focus is to be given for prioritizing this. So this kind of information can be generated using the satellite observation, and again can be given to the actual policy makers which makes the policy in that particular state and that in that particular division. This is what the advantage of satellite data for inundation mapping. Now this is another example. This is the previously what I showed is for on a complete state level analysis. If you are looking for more specific, very small region, so this is the Bindal River. It is in Dehradun. For different return periods, we can generate such kind of inundation maps, and you can zoom to the building level, district level, and you can see that which area, which building got inundated. So not on a local scale, state scale, district scale, but you can use this data set at a very high resolution for also for doing the different kind of analysis. Now just to I just add one slide here. Just to show that the satellite based the inundation that we do, that has to be validated, and then we are not sure that whatever the remote sensing satellite based observation that we use are how validated or how are in agreement with the in situ data set. So we do kind of surveys. So this is example that we try to do it in the Ganga river basin using the different instrumentations, like you have this GNSS receiver which gives you the continuous water level, and then all the this is the ADCP which give the complete profiling of the river. That again helps to improve the accuracy of different models that we use during the simulations. Now next, first we talked about the flood extent of the whenever the flood occurs. Now we'll talk about the water quality aspect of the river. Now for water quality also there are different methods where you can use the satellite observation data to do the water quality mapping. So out of this, only the optically active parameters can be utilized for water quality assessment. For example, turbidity is the one which can be easily mapped using the satellite data set. So there are different methods. The first one is the NDTI. So this NDTI is the normalized difference turbidity index. So all of us know we can, by just seeing the water level, we can identify whether the water quality parameters, specifically the optically active parameters like turbidity, color dissolved organic matter, color, temperature, chlorophyll. All these parameters can be mapped using the satellite data by using the different bands of the satellite data set that we are going to use. So these are the some of the examples. So here you can see uh,
Sir, slide is not moving.
slide. Still you are in the first slide, you are only able to see the first slide, or in between there was a movement.
It was moving earlier, but now it has stopped.
I will just try to share the entire screen. I hope it works. So I have shared my entire screen. I think it should work. Are you able to see this slide where Yamuna River and Ganga River is written?
Yes, sir.
Okay. So
There is
this,
Yamuna River and Ganga River.
okay. Thank you. Now this is one of the example of water quality mapping. Now here you can see that from the satellite image we try to map. You can see that there is a variation in the color scheme right from blue to red. So this is basically the representation of how NDTI is varying. Now here I can clearly see there is a variation in the turbidity along the Ganga River and the Yamuna River, and again in the after confluence. So such kind of visual, just by seeing visually, you can map that how turbidity is varying along the river, and you can quantify, and you can again divide the complete river stretch into the where there is a high turbidity, low turbidity. Such kind of analysis is quite possible when we use the satellite observations. So this is another image. If you could see the previous image of is was the month of May 2022. Now in the this is the image of October 2022. So this is the monsoon season where there is the heavy flood. So in the flood, during flood, you can see there is a increase in the turbidity, not only in the Ganga river, relatively increase in the Yamuna river. We can clearly see that there is a high turbidity in the Ganga river compared to the Yamuna river, and obviously when both rivers get confluence point at Prayagraj, the Sangam river. So there you can see accordingly there is a variation in the and increased turbidity we could see. So this kind of seeing the water quality aspect is also quite possible by using the satellite observations. So this is another image of January 2022. So if we have this complete time series of data set for different time periods, we can do the complete water quality mapping using the such kind of data set. Now next one is the first we talked about the flood extent, then water quality, and now the third, the important part, the parameter that we can address using the combination of different softwares and the satellite data is the minimum flow requirement. So when I started the lecture, so I was talking that there has to be the minimum flow to maintain the ecosystem of the river. Now, this minimum flow can be defined using the different standard definitions. So, you might have heard a lot about this environmental flow. So, now this what environmental flow is basically is the broader concept, or the what you can say the phrase where we try to see that minimum flow should be there in the river that will sustain the fresh water and the estuarine ecosystem. Not only that, the human livelihoods and the well-beings that depend on the complete system. So this all the water required for this human needs, aquatic system, complete a nearby dependence on that system is what the combined required flow we call as the environmental flow. Now, within environmental flow, there is another term is called as the ecological flow. Now, ecological flow is the you can say the subcategory of environmental flow where this discharge is required merely to maintain the river ecology. River ecology means flora and flora in the along the river and the aquatic system that is there along the river system. So this is why it is very important that what should be the ecological flow for any river, and this minimum flow has to be maintained to account or to maintain the aquifer system. So that is why whenever new project is launched along the river system, or if government is planning for new dam or any hydraulic structure, we should know that a minimum flow has to be maintained in the river, even if we construct a dam or we construct a barrage along the river. So that is why you might be seeing, even if there is a barrage, uh, you will see that there is a minimum flow always flowing in the downstream of the river. So what should be that discharge? What should be that river flow should be enough so that your aquatic life gets maintained at the downstream of that structure is very important. Now, in that case, there are various methods which can be utilized for this ecological flow assessment. This is where the two things meet. The what we can say, the core interdisciplinary approach is required to address this what we can say the problem. Not only the engineering background to assess this hydrodynamics of the river, but also to understand the which kind of aquatic life is there and what is the minimum requirement for those kind of aquatic lives. If crocodile is there, dolphin is there, fish is there, so each aquatic animals and the fishes, they require different kind of criteria of depth of velocity of the flow. So based on that, we can do such kind of habitat suitability for the different um, aquatic life. Now this study we try to do it in the one of the case study. This is the Mahanadi river. Now in the Mahanadi river there is one location, Tikarpara, and there is a wetland we call as the Satkoshia wetland. So in this area we try to assess along that main riverfront what is the minimum ecological flow that is required in that particular stretch to maintain the habitat for the particular fish, and what are the different steps that are required, we'll try to understand in this figure. So now hydrological method for environmental flow. So if the environmental flow, when I'm saying, means is just I want to know what is the river discharge in that particular river discharge. Normally we measure in terms of meter cube per second. So what should be it should be 100 meter cube per second, 200 or 150 or 1000. So it has to be how minimum flow should be there in that river. Now this minimum flow varies according to the kind of river. If you are addressing Mahanadi river, it will be different. If you are addressing Ganga river, it should be different. So that is why on a national scale, lot of efforts are going on to estimate the environmental flows for different rivers. So traditionally there are different methods out of this. This is the flow duration curve analysis method is there, and then uh, now this flow duration curve analysis method is what it tries to tell is that Q95 means what, throughout the year 95% of the time if that water should be there, that is called as the environmental flow. Or if 95%, so in between 90 to 95% of the time water should be there in that particular river channel where you are measuring the river discharge, that is what we used to call as the environmental flow. So this was the traditional method. Now there was some changes into this definition, and now people move to this flow duration curve shifting method, where not only just 90% or 95%, you do the analysis that magnitude of the discharge when it stays there water for 70% of time, 80% of time. Likewise, you do the 17 points you consider, and then you find out what should be the optimum environmental flow in that particular river. Now, in this direction, we did this for the Mahanadi River, and we found out that the around this is how the Q90 and Q95 is around 200 meter cube per second is what the discharge should be there in the Mahanadi River to maintain the aquatic life in that particular area. So not only this you can analyze in the spatial maps as well. So this is one of the uh, simulation we try to do it to assess to uh, earlier was the just using the discharge time series. Now this is one of the method where we use the simulations from the hydrodynamic models. This is we call it the Haycraft model, where we again same thing we use to assess the environment flow in that particular area. Now this using these simulations, as we can do the inundation mapping using the satellite observation, using the models also we can generate the depth maps. So you can see along the Mahanadi River, this is the depth and the flood extent map. This is the velocity map. Such kind of maps you can generate. Now along that river, what is the suitability for a particular aquatic animal or the fish. So this has to be targeted based on the kind of species. So now in this case we try to see the habitat suitability for the catfish. In the local terms we call as the shingri. So now to sustain the life for this particular fish, this is what the minimum required. I mean, based on the water depth, this is what habitat suitability index, like the water has to be in between 1 to around 3.5, then it is the ideal position where a catfish can survive. If water goes beyond less than this or the higher than that, higher than this 3 meter, it is unfavorable for the catfish to stay in that particular river channel. So likewise this is the requirement for different species. For like for this fish, ideal situation is water has to be between 1 to 3 meter. If it is higher than that, it will not work. Less than that, it will not work. Same case for the velocity. What is the velocity in that river or river current? What is the river current? It should be around zero point 0.3 to 1 meter per second. If that is the case, catfish can stay there. If velocity is higher than that, less than that, it will not work. So these are the habitat suitability curves that we call for this particular fish. Now using this curve, you can fit these curves into the models, and then we can find out the suitability at for the entire stretch. So we'll not go into the equation wise, but what I'm trying to show here is that uh, out of all the complete stretch, I can identify where there is a high suitability of this catfish can stay for a longer period of time, and where catfish can stay for a there is or where area which is unfavorable for the particular fish based on the some observations from the satellite data and the basic minimum requirement of that particular fish. So this is how the you can utilize again these different satellite observations like river flow, then DM, all this data that went to the models, which helps us to assess the suitability for the fish to stay in that particular river stage. So this kind of stage analysis also kind of can be done using this combination of satellite observation and the modeling approach. So based on this, for this Satkoshia wetland, we can say that around based on the second method that Q70 is the flow where or you can say in terms of 300 around 332 meter cube per discharge should be required to maintain the ecological flow into the Satkoshia wetland. So this is for this particular case studies we have done, but this can be reflected to or you can implement this into the different river stages of this India. So this is one of the example how that you can utilize and you can assess the suitability along the different stage. Now next one is the tourism and the recreation along the riverfront. Now we talked about the extent quality. Now the third most important component is also the tourism along the riverfront. Over a period of time, if you see, In India, Sabarmati riverfront is widely recognized. A lot of people are moving there, and now it has a lot of advantages, not only in terms of uh, the area where you can go and spend quality time with your family, but also in terms of the revenue generation for the government. Now government is looking into this aspect of tourism recreation, but to directly address tourism you need to look into the previous two components. What is the flood extent, whether that area is recurring flood is occurring in that area or not, what kind of water quality is there in that particular area or not. You, if you could achieve those two things within the allowable parameters, definitely we can create this river fronts which could become the tourist attractions for the different regions of the India. Now, just to address this, if you see, this is the major river fronts in India. You can see Sabarmati riverfront, as I showed you earlier in the Ahmedabad. Then Harkipur is there, Haridwar. Recently, if somebody is been to Rishikesh along the Ganga River, you might see that they have developed very good riverfronts on the both left and the right bank of the Ganga River in the Rishikesh. Now, creating these riverfronts reduces the weightage on the banks which are unlined. If people go number of times on the banks, there is a high possibility of the linkage between main channel and floodplain gets disturbed, water quality gets disturbed. However, if you create a river fronts, automatically you can as lot of regular maintenance gets involved. Not only you generate the revenue, but you get a very good beautiful uh, place to stay along the river. Now this uh, some of the major river fronts I have highlighted here, but there are a number of rivers throughout the India which can be converted into the river fronts. So why do we need? As I said before, it reduces the load on the unlined banks of the river, which again indirectly impact heavily on the overall the life of the river, the water quality. Now to address this we do need such kind of river front management. Now to do this, again there is a requirement of what we just talked. There is, we should aware of how satellite data can be used for different components of it, how the different interdisciplinary people, like I am have a background of water resources. Some people have a background of zoology who have a more knowledge on the aquatic life of the fishes, crocodiles. So this is what is required today to combine all this knowledge and come up with the riverfront. So thank you. This is